Yep, I'll make
Okay.
it quick.
So you have online viewers, so you have to love the microphone. So just carry, if you're going to walk, carry it with you.
Okay.
If I will monitor if there's questions online. If there's questions in the room, if you'll just repeat them. So the question was, and then answer it.
Okay.
And then I don't have a clicker, so you just have to hit the arrow,
Okay.
and you should be good. How do you want the lights, Kyler? You want them dim?
Yeah, you can dim them. Be fine. Got some pictures and stuff. Perfect. Wait, where? Okay. Oh, right there. You tell me when. I might need this screen. That'll work. Yep. Comfortable, calm, comfortable. Okay. We will get started. So, a little way of introduction. My name is Kyler Johnson. Lived in Utah pretty much my whole life. Live up in northern Utah in Tremont. Worked for New Sun Dairy in Korean. And compost has been kind of a little side project, I guess you could say, a little passion of mine that I've developed over the last couple of years. Really only been in farming for, this will be the sixth year. So I'm always learning, continuing to learn, passionate about learning, have a background in education, and so I've brought that with me to continue to drive this. Just click. Or do I have to actually press the next button? Oh, perfect. Okay, so there's a picture. My oldest, he's 5 now, but I think he was 3 in this picture. And he, kind of funny story, kind of has got a passion for compost as well. We just bought a house in Tremont in a newer subdivision. If anyone's familiar with newer subdivisions, they pull all the topsoil off and ship it away. And in fact, the day we were moving, I had my next door neighbor came over and introduced himself, and we talked for a little bit. And he gardens in his backyard, grows a couple of vegetables and whatnot, and he's kind of passionate about that a bit. And I said, oh, well, funny story. I'm in farming as well and into compost. And he says, oh, you're into compost. And so we talked about that, and he warned me. He says, I've lived here for 10 years, and I was one of the first houses in this neighborhood, and I've never seen a worm in my yard, period. And it's really. And so over the next couple of weeks, we started moving in, getting comfortable, decided, you know what, let's plant a garden this year. And so, sunk a shovel into my little garden beds I had planted around my house, and what did I find? 0 worms. Hard packed clay ground, just nasty stuff. So I brought some of my compost home and let my kid shovel it out there and throw it in, and he had to get rid of all the yellow dirt. That's what he called it. He says, it's time to get rid of this yellow dirt and put good dirt in here. So we did that. And we've seen, I don't have pictures on this slide, but I can go out there right now, dig my hand into the ground, and I can't find a clump of clay in that ground. It's completely changed the structure. So there's a picture. This was taken, Tuesday morning, I believe. This is our compost yard at the moment. It's got a couple wet spots in it, but Doug's here. He's kind of the compost turner man, and we started turning already. So this kind of gives you an idea of the scope, a little background about us and our operation. I would consider it fairly large scale anyways. Animal numbers across 3 different dairies, milking a little over 3,000 cows. I don't know how many we have in the feedlot, at least that much. Yeah, another 3,000 replacement heifers, calves. So yeah, right around 6,000 total. At that feedlot, the growing pens, they are bedded on straw pack. Corn stalks, we did a little corn stalks this year, and so that's where we're getting the majority of our feedstock to produce our compost. There's an overhead, kind of the size and scale of the compost yard. Yeah, and we'll bring in the feedstocks, compost them down, try it, at least twice a year, try and get more if we can. The types of compost we're really making 3 different types of compost. We're making a bedding compost that we're breaking down and putting back in our freestall sheds as a comfortable bedding material for the cows. And then we make a mortality compost with our dead cows, and that's really where we started putting out on the fields, high nutrient dense compost, and it's really dense like dirt, black dirt. And then I started, this is like my little pet project, the field compost. And so the picture on the left, that's our bedding compost. You can see it's really fibrous. You grab a handful of it and it's spongy. And then the stuff on the right, that's the field compost. That's the compost that the last batch I just made last year. And it's, we're spreading it on fields, yes. I haven't noticed any oil spots. I mean, it's, and we're not putting it out super thick either. Yeah, we haven't noticed anything negative about the mortality compost going out. Yes. The question about bones in the mortality compost. So the bones, and maybe Doug's better to talk about this than I am, but I've listened to him talk about it a couple times. The bones that we see, the ones that are left over get screened out, and those are usually the bigger bones, leg bones. We'll get some vertebrae still left in there, but for the most part, anything small is gone, broken down in the compost, gone, disappeared. And so anything that's left over, we do screen that, and then we haul that off. So why are we composting? For us, really out of necessity. It's expensive for us to bed with sand. It's really our best option. We have a ton of raw starting materials, the feedlot. We got to clean that out every once in a while. It builds up. We have raw manure we need to get rid of. So the compost has really been a good option for us. Traditionally, the liquid manure we go haul out to the field, lots of it. And we'll get into that in the next slide. And so we see a negative effect upon the soil condition, structure. And so with compost, we can break that down somewhere else, capture nutrients, and then apply those in a more, and less, what's the word I'm looking for? I guess we're spending less time and money spreading it out as compost rather than hauling it as manure. So the liquid manure application, we kind of figured out our loads, and we're running about 5,700 loads across our fields. And gallon-wise, across the year, it's like 20 million gallons we've decided. Each field will get 200 to 400 loads depending on size. That's a lot of heavy tractors going in and out of each field, across the top, across the bottom, throughout the field. You can imagine what the headlands look like. They're super hard and dense, essentially dead. And we try and manage that during the winter, going across some frozen conditions, and that does help. But with each field, we see compaction, we see nutrient loss, and really it's extra work to get that material back into the ground. We got to make an extra 2, sometimes 3 passes to get that manure back in the ground. So here's out at one of our dairies, Sunray Dairy. We have a big pit. I don't know what the gallons is. What's the gallons on it? Have about 4 million gallons holding. And we have to go out 3 times a year and clean that out. So we pump it out, put it in these spreading trailers, haul them out to fields. And it usually takes us from start to finish to clean that. It takes 5 to 6 guys, 2 weeks straight, hauling, 8-hour days or more. There's them out in the field spreading. I think when this picture was taken, we had shut down the lagoon because we're building a separator out there. So this is really watery, but spreading water out on a field. Here's a video they took. How do I play it now? So in that bottom corner, you get a glimpse of the holding capacity of the lagoon that we're building. I'll get a little bit into that here in a second. Should have prefaced this with a trigger warning to anybody that's had experience slinging manure. Trigger some PTSD. I don't even know how long this video is. But in this, you kind of get the idea, those of you who haven't had experience with it, what it takes to get this kind of material out, the time commitment. the stress on the ground. Now we're gonna have to sit here and wait for this field to dry enough that we can actually get onto it. And during that process, we're gonna lose nutrients that the manure has. It's just gonna be volatile and get out of or escape. So really, we're losing a little bit of the benefit of what the manure has to offer, just by timing wise, as we really don't have a good way to inject it straight into the ground. Yeah. Yeah. Yeah, so for those online, Mitch was bringing up the context of this. Cost-wise to the dairy, I mean, to put it on like that, it's going to take 2 weeks to run it out. And really, we have the 3 dairies, so really when we clean out a dairy, it's taking us 2 weeks at each dairy. And that's, for that 2-week period, it's costing $50,000 or more to run that equipment, to run those guys, to pay them to do it. So yeah, it's costing quite a bit. Cost that's, I guess, necessary, but if we can get away from it, that is the goal. Whoops. Okay, so that brings me to manure separation. So we have a separator at one of the dairies, and that's, I don't really know, I guess that's really where it all began, and that one was funded by us solely, correct? And then this manure separator at the dairy that we just saw the video on, the Sunray Dairy, with the partnership of NRCS, we're putting in this manure separation system to get away from having to haul any of that manure. So that existing pit, I guess they engineered it out to have that pit be a holding area for water. And then in that, I guess, let me go back to that slide. I'll just leave it at the slide if I can. Oh, I know I'm going to have to go to the video. Right there. So you can see the tractor out in the, I guess really the main part of that. Tractor's in there moving dirt. So we had to build a holding lagoon to hold, what's the gallons total? 4.7. Yeah, 4.7 million gallons of water. We have to have holding capacity for that dairy. So we had an existing lagoon there, and then we designed it so that bucket's running off GPS to increase our holding capacity out there. And that's just an evaporation pond. So it'll go through a series of separating ponds where the existing manure pit is, sand separation, fine sediment separation, and then eventually go out to that lagoon to be evaporated, or that ditch you can see across the field is actually piped. And we can pull a head gate out of the lagoon and send that water to a field, neighbor's pasture, and that works out really well for us as well. So then that picture on the right-hand side is the ending material. So it'll come into the middle picture, get scraped into there. There's rock separation that happens there, get pushed across from that left picture. That's the separator, so it'll gravity feed down there and then squeeze the rest of the water out. And then we're left with the right-hand side. So that's our new raw material. We call that green waste, pressed manure. And so that is what we're left with, the water and then that green waste. Now, what are we going to do with these solids? So we could spread the solids. Yes, we could get a spreading truck, spread the solids out in fields. just a light layer. Use the solids in a compost recipe, and that's been kind of my driving force and goal behind the compost, to use up as much of the green waste as possible. And so with that being my driving force, it was important in my recipe. So I prioritized green waste in the recipe, and I wish I would have provided my little spreadsheet that I use to create a recipe, but I have parameters in my spreadsheet. So I know what my carbon to nitrogen ratio needs to be. I know what my porosity needs to be. I know what my moisture needs to be. And I know what these starting materials are because I've tested them. So I sent tests out, got back those values, so I know what my green waste values are. I know what my straw pack values are. I know what just a dry, rotten straw bale is. We have mint, leftover spent mint from a neighbor that we use, so I know what that is. Plug those in, shoots out how much of each thing, so tonnage-wise is what I have it given me. So then I'll weigh my trucks, put them in. So in this picture, that's a line getting ready to be turned for the first time. So we just built that line. It's got, straw pack from the dry lots. It's got the pressed manure from the separator. It's got mint. It's got, the yellow you see on top of that's clay. And I used the clay kind of as a binding agent for capturing nutrients. It actually worked fairly decent, but then this last year I didn't use it at all, and it worked about the same, seemed to be. So I don't know if clay is necessary. In fact, in the future I don't think I'll use it, but that's part of the experimentation and learning that we are doing. And I've been able to, I guess with that recipe and that recipe builder, I've been able to adjust the recipe. So the first year had all those extra materials. This last year we were a little bit more stretched and limited with the starting materials that we had available. And so I had to adjust my recipe. So I punched my numbers in, shoots out what I need, and I got a very similar product because of it. The composting process, talk a little bit about that. Building the lines is fairly time consuming, and I haven't really figured out a better way to do it than how we are doing it. We have chain bed trucks, silage trucks, I guess, that we use strictly for manure. And, you go get loaded up with straw pack, you haul it out to the line. And because I knew what tonnages I needed, and I guess volumes, and the trucks, I knew what the trucks generally weighed, I had to space them out to get so that was kind of a pain, I guess, get the drivers to space out their dumps so that I could get everything in the line that I wanted. So once the lines are built, start turning. We have a turner, self-propelled turner, that really does a good job of aerating the material, opening it up, because compost going anaerobic is bad news. Well, really anything, soil going anaerobic, everything is bad news. So the aeration of the material is very important. Maintaining the temperature, especially those first, I'd say probably 4 weeks, is important. But if you have your recipe correct and your everything's balanced, the temperature is just going to naturally come. Maintaining the moisture is an issue at times, especially for this field compost. I've been applying moisture through a water truck and a spray system. That's the picture on the right that you can see. Maybe it's kind of hard to see. Anyways, the truck's driving down the line. We built an arm that reaches out over top of the line and sprays water down on the top, and then the turner will go in right behind that and incorporate that water. And that's how I've been maintaining the moisture, trying to keep it around 50% as much as possible, and that just aids in the breakdown. Obviously if we get too wet, we're going to be anaerobic, but the moisture I've found to be fairly important. Yes?
Is that like clean water, or is that water like from
So that water is water I'm pulling straight from the canal. So that's just canal water. I could, I suppose, and we've talked about it, pulling out of our evaporative lagoons that water, but I'd probably have to do that the first little bit until, I don't know what that cutoff time would be. Just injecting new bacteria back into the pile is not ideal. But the first couple of days I probably could do it, especially if I need my nitrogen higher. So in that compost process, especially the first 4 weeks, very important breakdown process. That's the process we're familiar with. In those first 4 weeks, you're going to see a reduction in volume down to right around half, maybe we're not quite half, but so we're breaking down the material physically and chemically. And this is where we could run into a little bit of trouble, especially with things going anaerobic as we break down. The density is greater, and so the aeration might be a little bit more difficult to accomplish. And as things go anaerobic, things start stinking. And so when you're smelling those volatile compounds, that's when we can assume that, yeah, we're probably anaerobic. But then, after the breakdown period, what I've been trying to do, and I guess one of the important things, is building it back up. And that's something that not very many people think about in compost. You know, we always think about breaking things down, but building back up is very important as well. And part of that build back process, I shouldn't say build back better, huh? I might get myself in trouble. Yeah, I didn't say that. You didn't hear that from me. Anyways, some of that building up process is the humus. So you hear humus. People have heard of humus. Humus is important. So we took tests of this compost while we were breaking it down, and I can't remember the dates. I was maybe 8 weeks into it in about a 16-week process. Tested the compost, sent them off to Midwest Labs, and they shot back what humic ions I had. And they were pretty good, really. We were excited about it and promising. So the humic ions are then part of the things that are being built back up. And as we build a humus protein or a humus product, then we can see those humic ions going back down a little bit. And we saw that in our tests that we tested towards the end. And then the compost goes through a curing process and really stabilizes, dries out a little bit so we can apply it to our fields. That's kind of the basic process of what we're doing composting. A picture of our turner going. This is kind of a neat video. So this turner, how many years have we had this? 2 years? 3? This will be the 3rd year? Or this will be the 4th year. Yeah. Before that, we were using a turner with just, what do you call them? Just knives. A knife turner. Yeah. And now this one's got scoops and really does a very good job of, I guess you'd call it handling each product, opening it up. It doesn't just slice through everything. It picks it up, fluffs it up, aerates it. You can see all the steam coming off that. And really, you can see the steam coming off, I think they say, I've heard at least, anything 15 degrees over ambient, you're going to get steam like that. But at that point in the process, we're probably coming down in temperature, but I'd say we're still 100, 110 or more. We're really trying to get that 130, 140 to really break down those bad bacteria and bad microbes, killing weed seeds. Kind of gives an idea of the size and scope we're dealing with here.
How many times do you have to turn each pile?
So especially early on, we're turning every day, or close to every day, with a pile that size anyway. The stuff in the middle is going to go anaerobic within a day, easy. And we last year, or not last year, the year before that, the first year we were doing this, I had a CO2 tester that we were using to stick into the pile, and you test the CO2 levels, assuming, well, the science behind it, I guess, is as CO2 levels rise, your oxygen levels are lowering. So once your CO2 levels hit 20% or so, then you can assume that your oxygen levels are pretty much zero. And then it's time to turn, and that was happening daily. Sometimes you could probably even get away with turning it twice in a day, early on anyway.
So you look at making a smaller row to help with
Yeah, sorta. The smaller row is difficult, I guess, for me. Just the way we're handling material with the trucks and side dumps and loaders and the larger lines. Well, my intentions the first year were small lines, but they turned out very large. In fact, the first year, my intentions were to make lines half the size of that. And then once they got broken down, I would then combine them so that I was managing less material, or I guess less rows, making less passes, but those lines ended up being large and in charge. And we just stuck with it. But yeah. How many tons? Ooh, I had the math on it, but I don't remember. 700 tons? Yeah. Yeah, those lines are about 1,000 feet long or so, 900.
So back to Corey's question, one line can return 20 times?
Yeah, I'm turning every day for 16 weeks or so.
Or every day for 16 weeks on the same line?
Well, and I don't have to go every day. So I'd say the first 4 weeks, you're every day. Yeah.
How do you stick to that?
Yep.
I think temps are trying to maintain the temps in that line between 130 and 140 to 50. If you get much more than that, then you're gonna basically turn the compost to ash and kill everything. So we want to maintain around 140 degrees, because that's where we kill the weeds, seed and everything. And based on those temperatures, and I started turning compost in 1994, so I have a little bit of gut feeling, if you will. So I can walk through my lines or drive through those lines and tell you, just from my experience, if they can turn or not. If that makes sense to you. Some get turned every time, some don't. Just depends on the feedstocks that went in. This year might be a little different. We said it was corn stalks, so we can have more porosity, more to break down. So depending on how that's cooked, we've never done that. So it's a new adventure for us this year. We're putting out trails to see how that progresses. But we really turn the line when the line tells us to turn it. Too high a temp, we're going to turn it. Too low a temp, we're going to turn it. Get oxygen back in, let oxygen out, let the heat escape. That machine that we have really works well because it picks everything up from the bottom. And as I move those lines, I can see straight marks from my drum. If I'm not paying attention, it'll actually leave drum marks in that clay or in that soil. And even at that, there's still a sludge on the bottom, so we have to flip them. So it's kind of labor intensive and time consuming, but
That's probably
pay
the
attention to what the line's telling us.
that's probably the biggest labor, right? I mean, how long does it take you to flip a line over? And you can probably do 2 lines a day if you're hauling.
Yeah.
Yeah.
About 4 hours. It takes about starting out, it takes about an hour to go through a line starting out initially. But by the time you cook it down and go through the process, flip it, you're doing with less material than you would about half an hour. So
Well, and I guess that's one part that I skipped over a little bit, but I'll just for the people online, I guess. The line determines when we're turning it. I guess is probably the best way to say. Like we can say, oh yeah, we're going to turn it every day, but there's times it doesn't need turned, and so the line's going to determine that. But that's, I guess, a part that I skipped over a little bit. So you see these lines are not static in the same spot every time. Like the very bottom of that, like Doug said, is going to be wet and sludgy, and you want to get rid of that. So there's a lot of benefit to flipping that line, to come in with a front end loader, flip that line over onto fresh dirt. And now we keep turning after that. But that really helps because you're going to get anaerobic stuff on the bottom. You're going to get nasty stuff on the bottom, and at some point you're going to have to get that off. And that's why we flip lines over with a loader. No, they're too big.
No, all it does is push it, it just makes a mess. It doesn't top to bottom, it just pushes it.
So the majority of your compost goes back in the bedding.
Yeah. So in a yard, how many lines we fitting in there? 14, 15?
22 lines in that.
Oh, 22 lines in that? Yeah, so we'll go 22 lines at least twice a year. And of those 22 lines, well, so if 2 of those lines are field compost, the other 20 are going for bedding. So yeah, we use quite a bit of bedding.
Can we talk a little bit about the difference between those? I know you were talking at the beginning, you have 3 different types of compost. So kind of what is the difference in those and how you prepare those?
Yeah, so the preparation, starting materials maybe differ a little bit. The bedding compost is solely straw pack and green waste, the pressed manure. And that really kind of depends. Like there's times that we'll get straw pack in that is sopping wet, times that some of that stuff is not. And so you got to add a little moisture in it. You're trying to get that 50% moisture. So the green waste is very high in moisture still. Well, I say very high, it's not sludge, but, and then if we have to add moisture to that compost, we'll even come in with raw slurry manure out of those spreaders and spread straight onto the line and then incorporate that in that way. And so really the difference in starting materials isn't that much. I think, we don't really add water through the truck to the bedding compost as much unless it's absolutely necessary, like if it's like bone dry, because really the end goal in the bedding compost is have something that's clean, free of bacteria, comfortable, and dry. And so that bedding compost right in front of us there, that's going to get dried down essentially to a powder, and that's the goal. Where the field compost will stay higher in moisture basically until the end. That curing process is maybe its drying process. So we'll let it sit in line, turn it, I don't know, once a month, just to open it up, air it out a little bit, and then gets applied to fields. It's better for us to apply it when it's dry. It comes out of our truck better. Does that answer the question? Okay. No, I have not really. I guess the fungal load and bacterial loads fairly new to me in the last year. I mean, obviously we're trying to get rid of the bad bacteria that's in the manure. And so we've sent tests to the lab for those, basically for the bedding compost. The field compost, though, I was never necessarily concerned with the fungal load. And maybe some of you know who I've dealt with that compost, if I say the name, but maybe I'll keep it private for now. And that individual is selling a product that's not, he's not really concerned with the fungal load. He's more concerned with the humus product, and that's kind of where I was going at first. And then I've more transitioned, I won't say out of that humus product, transitioning more to being more concerned with the fungal load and the bacterial concentrations. And that's kind of where I'm heading now, as I've done a little bit of research on the side. But no, I've not taken a sample, sent it to a lab that can do that. I haven't looked at it under a microscope, so I don't know for certain what's in it, if that makes sense. So get into what we're looking for in a good compost. We talked a little bit about the bedding compost. And these 2 pictures are the 2 lines that I did last year. The picture on the left was the mixture, the recipe with straw pack in it. That had straw pack in it. That had green waste in it. That had mint in it. And I think that's all I had in that one. And then the one on the right is strictly mint and pressed manure, green waste. That's it. And you can see they're similar. The one on the left's got a little bit more moisture in it, but I guess I take that back. That had a little bit of raw manure spread onto it as well. So it's a little bit wetter. Smell, I can take a handful of it and smell it. I smell zero ammonia. I smell zero manure. You can just smell I don't know how to explain it, good organic material. What's that? Yeah, it smells like earth. The color, it's dark. It's rich. The texture, and I pick it up in my hands, and maybe one of the things that I'm gauging off of is those little aggregates, little nodules that you see in there. And I've been told that those are very beneficial those are kind of bacterial and fungal housing units, I suppose you could say. And so that's where I'm going to see a lot of the benefit of soil aggregation through that. And so I kind of base that as a measure of quality, I suppose, and maybe that's wrong. The humic load, I've done tests through Midwest Labs, have the humic ions, and I kind of have an idea of where they were, where they are at the end. And then bacterial and fungal, that's kind of where we'll be transitioning this year and further on. Benefits, we've talked a little bit about the financial benefits of not having to haul manure, not having to spend that $50,000 every 2 weeks on labor and tractors. I don't even know, does that even include fuel? That does include fuel, okay. Wear and tear on equipment, maintenance, wear and tear on my body. I'm just kidding. So financial and equipment savings, we can switch away from having 6 or 7 pieces of equipment at times, and turn that down to being able to fill a compost yard in 2 weeks, and then 1 guy or 2 guys turning compost while everybody else can focus on other things. The other benefit that we're really pushing for is the soil structure improvement. We're not having 400 slingers run across the field every year. We can take one spreader truck, load him up, a handful of times. I can't even remember how many loads I did out on a 40-acre field, maybe 10, 20 at the most. One truck with floater tires on it, spread it out. So that picture on the right, that's the hay field. So I've put compost on that for 2 years now. This is the 2nd year, and you can just see it's just a fine dusting. I scraped a little bit with my finger just to kind of give you contrast. Maybe it's kind of hard to see of what's underneath, but then you can see the darker material on top. It's just a fine dust, 3 tons per acre. And with that, I have a very limited data selection, I guess, with it only being 1 field and 2 years worth of compost, really 1 harvest out of it. But with that, I've got that 1 field, and then one half a mile away that was planted the same year, had the same work done to it. They were both laser leveled. In fact, this one probably had more soil moved off of it because we were changing the way it watered and combining fields. And so this field actually produced 1/2 ton an acre more over the year than the other field. And they have the same fertilizer, everything's the same year. And so we're looking to expand that and kind of get more data off of the fields that we've done. Well, we did every single hay field this year and a couple corn fields. So we want to increase nutrient availability and give power back to the plants. So this is where I guess my little passion and what I'm looking to improve the most. So we want to gain the most out of our fertilizer that we possibly can. Fertilizer prices are going crazy. People are stressing. And we touched, Dr. Jill Clapton talked a little bit about it with the microbes and the mycorrhizae. And so that one gentleman, I don't know if anyone knows him, Edwin Blosser, but he talked a little bit, and that's his big thing with the humus compost. The humus being a food source for the bacteria, the fungi, and basically creating a shield around the roots of the plant. And so then you get those exudates. We all talked about the exudates before. And having those bacteria, the fungi, then essentially providing the plant with what it needs, giving the power back to the plants. So there's I should have put a slide of that on there too, but there's a nutrient gradient. I don't know if anyone's familiar with nutrient gradient and the availability gradient. So you take a list of all the nutrients in the soil, and they each have their own availability to the plant. So things that are higher up on that tier list are going to be more readily available to the plant. The plant's going to uptake it naturally, leaving the stuff at the bottom basically to fend for themselves. I don't know, maybe that's not the best term, but if we're giving the plants the bacterial, the microbial life to protect and feed the roots, there's actually research to show that plant is now available, or the nutrients are available to the plant. The plant can pick and choose, with the exudates. It says, oh, I need this, and maybe that nutrient is not high up on the list, probably lower up on the list, but it's needed, right? So then the plant can then take that up and use it when it needs it, rather than when we flood the soil with the fertilizer. So that's something that I'll be looking into and seeing the improvement of the soil structure, improvement of the plant health as we progress with the compost. And the compost is basically just a medium to improve the soil. People are probably familiar with Elaine Ingham and her process, and her big thing is the compost as being the best way to get the microbial life back into the soil. It's the best medium, best vector to get it into the soil. And so that's, I guess, what we're trying to do, trying to be progressive and improve our soils. Yeah, that's about all I got, yeah.
Online question, are you incorporating compost in alfalfa applications?
Nope. So we are not incorporating the compost into the alfalfa. So I will spread that on in the fall, and then it'll sit in the winter. Hopefully it gets snowed on, soak in. It's kind of the idea behind it. But I'm not tilling it in or nothing now.
What about on a grain program or corn?
I would, so we are still doing conventional tillage. And so we have spread some on cornfields. Same deal, did it in the fall prior to planting, in the spring, let it soak in, and then, just regular tillage program, and that's the incorporation for that.
Are you double cropping grain?
Yes, yep.
So you put this in front of both of those? Or just in the fall?
So we've done it limited with the corn. We've only done it in the fall, but there's no reason why we can't put it on, so we're double cropping with triticale corn. And there's no reason why I can't go in, spread it, and then, yes, in the back.
What do you use to measure your nutrient value in your compost? Do you have an idea of what you're finding?
So,
How do you determine what each property, do you do the soil testing stuff still?
so to measure the nutrient value in the compost, we are still doing soil samples and tests to figure out, and that's part of our fertilizer program. And I also have compost tests, so I know what's in my compost, so I know the nutrients. But at least for me, the nutrient level of the compost is maybe just a bonus. The compost is not I'm not using it as a fertilizer or a direct fertilizer substitute. Those effects, the fertilizer value, that's just a bonus to us. The real effect is getting that microbial life in the soil. So that's our biggest thing. Does that answer it, or did I not get? Yeah. Yeah, and that's been a concern. That has been a concern, but we have not seen any effect of the sodium. So we did measure sodium levels in the compost, and they're not crazy. With it being dairy-based manure, they are, it is high in sodium. It is what it is, and I haven't really found a good way to get rid of it. Applying it at 3 tons an acre, putting that on there, letting it soak, letting it sit all winter with the snow and the runoff, soak in. We flood irrigate, and so we don't find the sodium being an issue. Exactly, yes. We would be less sodium with the compost rather than the liquid manure. Yeah.
That's my question is, what would your sodium levels, have you seen your sodium is obviously decreased from going from the liquid application to compost. Been able to quantify that?
I have soil tests, but I don't.
This process has been a process we've been trying to work on as we go dairy to dairy. So dairy is tied to the land mass, and the land mass goes through this process of compost versus slurry application and tillage. The goal for all the ground we run is to eventually get to less tillage, more organic and live living matter in the soil. So specifically to speak to the field Tyler's trying this on now, we've got a couple of trials, and both of these trials go 2 to 3 year rotation with slurry manure, just because of the location and the footprint in proximity to the dairy, and as such requires conventional tillage, and as such kind of resets the clock every period of application. So as the dairies move through, we'll know more and more about how the compost provides benefit long term. Salts and salinity, yes, we've seen some decrease, but then those volumes tend to unfortunately increase and kind of reset when the soil goes out, and we go out to the
Yeah. And in the future, we hope to be able to put separation systems at all the dairies to limit that slurry application completely, or at least, only when we have to clean out, Instead of hauling 20 million gallons a year, we're hauling a couple million. But yeah. Yeah, and that's, I don't know, I have what to say to that. So that's part of the,
we have soil samples.
yes, we have soil samples.
And it proves that there's human products being created. But part of the problem we run into is the samples are taken from the Midwest bio labs, and we don't interpret suitable, and our Western process of farms doesn't interpret the Midwest labs the same. So the volumes of level we read positive increasing, yes, but how that affects what we are seeing and why we're seeing what we're seeing, we're still a little bit of a it's reading in labs, yeah. Yep. Where's the Midwest labs?
It's in Nebraska, but they're talking about a different labs in Nebraska that might be better for that. I don't know exactly what they test for, but Midwest Labs, and they'll test for the humic ion, but concentrations of humus in the soil, I haven't seen that from them. Stukenholz doesn't do it either.
So do you apply less fertility because of the humus that you're adding, or what?
Do I have less fertility?
Are you applying less fertility because of
Oh, yeah, we did cut back. I don't know what the value is. Percentage of fertilizer we did cut back on those hay fields.
I know 4 or 5 growers in here that could tell us.
Yeah.
But, yes, we've got, the last 3 years, gotten away from our fall application of fertilizer on hay fields and replaced it 100% with this, field compost that we, the compost that we use in the product. I don't want to give you the perception we're applying a humic product that's
Right.
but we have replaced our fall application for 100%.
Yep. And that was,
Based on everything.
yeah, based on NPKs. We did reduce the amount of fertilizer that we used with this application of compost.
Are you familiar enough with your base saturations on your soil tests to comment on what's happening on your base saturation level?
I'm not, no.
What about your agronomists?
They're gone here.
Oh, right.
We just visually, and we talked a little bit about this last night, just visually, we see the soil transforming and the compaction levels we see across the field vary due to traffic, truck traffic, and corn especially, and manure application. And so as we focus on those areas of high traffic and compaction in those areas, we do see that permeability and the aeration increase, not only because of the lack of traffic using compost rather than hauling out gallons of water,
Yep.
but because of the product reacting with the soil and treating that environment as well.
Right. So it's kind of a double whammy. We are lessening our tracking on the field, lessening our trips. The slingers aren't going on there, the trucks, and that's just unavoidable where we are silaging everything. But the slingers mitigating that as much as possible. The compost truck with the floater tires are doing way less than what the slingers are doing, just constantly bouncing in the field. And then yes, the goal is to change the soil structure with the compost, getting with that or from the microbial impact and injection into the soil basically. So that's where we're looking for the benefits. So it's kind of a double benefit doing the compost rather than pure liquid manure.
In your rotation, I assume you're doing alfalfa for 5 years, and then
Yeah.
you do a corn grain, double crop for 5 years, and then back, or how's your rotation look like?
Of the 5 years that it's in corn, 3 of those years will be double crop. 2 of those years are left, and then the 6th year goes back into a cereal sort of grain to increase seed.
Direct seed on the alfalfa.
Yep. Yep.
What's your, if you don't mind sharing, what you think the value of what you're doing is, quantifying that, and the costs that are involved, or how are you valuing what you're doing, I guess, what are the costs, and how are you valuing?
Yeah, so cost right off the bat with fertilizer, and maybe I should have been more prepared with those costs, but
With this last 2021, based on the values in the compost that we sold, and I don't want to say commercially, so we do it commercially yet, but what we sold to sod farms and other neighbors, big growers, honey growers, things like that, has been based on NPK, and it's put us in a value of $40 to $42 a ton.
yeah, yeah,
On our operation, we are in the realm of, and depending on the labor intensity and depending on the type of compost that we're creating, you can make scoop better than that, but we're anywhere from $14 for the same time, $14 to $23.
yeah.
And what are those NPK levels?
I can pull up the soil sample shows, but to speak directly without memory, that box is in somewhere else. But we have soil sample right now, show that.
But not this, when you say soil test, you mean compost?
Compost tests, yeah. Yeah, and I don't have those Stugenholz tests with me either. I have the Midwest labs, but they don't measure the NPK the same as Stugenholz does.
So am I understanding, so the turning process, I mean, daily kind of took me off guard. I thought that there was a lot more time between the that the nature of what you do in here? You have to turn it more often, or am I just missing the boat on the normal?
I would say that's probably fairly normal for people making a similar product. Yeah, yeah. Yeah, there's a lot of composting operations that are more of just a putrefied mash of organic material is probably a better way to put it. But
You know, the question was asked financially for the company as a whole. The field compost is something that we're starting, and we've been doing bedding compost for about 10 years now. The value of that bedding compost, we actually did some of the bedding compost in the fields before we started this. But that value on that, we purchased about half the straw that we used to. We've done tests on the soil, on that bedding, and we've done tests on our sand, and the compost is cleaner than the sand. So for the cows, it's a clean material, it's the financial benefit, it really has improved, because we're not spending as much on buying outside products, we're using it all inside, which is leading us to be more conservative. We use what's in-house, we don't have to bring outside sources in. Just save money.
yeah, yeah.
We run about a dairy average, we're running about 60,000 snack cell count across all 3,000 cows. In compost.
Yeah, so especially for us dairying, having that bedding compost, that's been, I mean, and you can stick a number to it, but it's I mean,
It's taken us 50 years to get, with all due respect to those who preceded, it's taken us 50 years to get to the position we're in. And we're very optimistic it's not going to take 50 years to get out of that as we practice better thought process. And as we implement and perfect this compost process we're doing, we expect to see results a lot faster.
yeah. And that's just the nature of the research that's been done. I mean, there's such a push for soil health, for better progressive practices, and we'd like to think we want to be on the leading edge of that and pushing for that. And this is what we see as the biggest benefit to us and our best way into being better stewards of the land, because and there's times we cannot get away from the tillage. There's times that we can't get away from the pesticides, herbicides, and fertilizers. And so the compost has been our way into this realm of improving our soil health. Yes.
Some fertilizer, like 16,6A, that's an example. What would the composition of this be?
I have tests, yeah, but I don't have them pulled up. If I can get those for you and show you what they are. He was asking, based off of like a fertilizer blend, what's the NPK on the compost?
We are on a dry matter basis, carbon's 1.6, the ratio 15:1, mixed with nitrous, you can send 2.6, magnesium 1.6, sulfur 0.6, there was a 0.34% P, 1.87% K, PHC 7.6. I can share that with you if you like to. Part of the inputs create mint specifically. It's metal that creates a high possibly less than ideal
Yeah.
results on some of that.
Yeah, the mints, we've been back and forth on the mint, whether to use it or whether to not. The mint is good in some things and bad in others, but that's still learning. And it does smell very good when you're turning it. Okay, yeah, I'm past my time, so thank you.
Thank you.